Hi, everybody. My name is Aaron Krickenberger. Today is Tuesday, March 10th, and you are at the Kubernetes SIG Testing bi-weekly meeting. We adhere to the Kubernetes Code of Conduct, which basically boils down to don't be a jerk. This meeting is a public meeting and is being recorded and will be posted to YouTube shortly. On today's agenda, I just wanted to kind of review a couple neat or interesting PRs that have merged in the test info repo lately. Eric's going to talk to us, Eric Fade is going to talk to us a little bit about workload identity and how we're using it for the Kubernetes Prow instance. And Catherine's going to talk to us a little bit about a proof of concept for caching the Go cache. So let me go ahead and share my screen to help me walk you through this. Which Google Chrome instance is it? Okay, so we should be looking at the meeting notes. Move the Zoom thing out of the way. So the first thing I wanted to call out was the fact that JetStack has a number of Prow jobs that they want to show up on TestGrid. And they're being good open source citizens. So posting test results for things related to Cert Manager, which is a really useful thing for managing your certs for Kubernetes via Let's Encrypt, to the testgrid.k8s.io instance. But the way this is being done now is by using a script called transfigure, which we've had out for a couple months now, which allows people who are running their own instance of Prow to generate a test grid configuration file for use with our instance of Prow. So if you want to see how that was done, this PR is a great example of how to do so. And this README will tell you more about how to use transfigure, including giving you an example of how to replicate the Prow job that they're using. So something else I noticed, that the PR itself is just called refactor IO package, but it's kind of burying the lead, because the reason it's refactoring the IO package is to add support for S3 to a couple Prow components. Eric, I was wondering if you could talk a little bit more to this one, because I wasn't really involved in the review of this PR.
Yeah, so there's inside of test info, there's the package IO, and it sort of provides an interface for creating a reader and a writer that we've used to like some of our components, which is this one's targeting. You can sort of basically change whether or not you are reading and writing state from a local file system or Google Cloud Storage by just changing the path. And this is extending it to also support S3 buckets. And so I think it's pretty nice, because it's sort of the way it's designed is it will allow you to not only support S3 if that's what you want to do exclusively, but also theoretically if like some of your stuff is in GCS and some of your stuff is in S3, you'd be able to have some jobs write to S3 and other jobs write to GCS if that's interesting. And the interface thus far is pretty clean. Sort of the people who are using this interface don't have to know where the writing is happening. This is sort of handled by the package. And yeah, so the three of us, I guess, on this PR sort of were chatting about this and did a bunch of reviews. I'm pretty happy. This is a cool contribution from somebody outside of the core set of people. So maybe this is a good example of someone who is contributing new and exciting functionality who isn't one of the standard people working on Prow. So that's really cool. And the intent is to sort of get it working with the sort of initial components like Tide, and then extend that to the rest of the system like pod utilities, etc. so that basically anybody who's using Prow can, use S3 or Google Cloud Storage. And the S3 support is the way it was done. It should be easy to add other providers in the future as well. So yeah, so I think that's very exciting.
Cool, thank you. Yeah, when I heard S3 support, I immediately thought of pod utils, and this seems like it's a little further back than that, but it's really useful to have some of the components start using S3 pretty transparently.
Yes, so I think he actually has a fork, or he has his own version of it that is using the rest of the system using S3, but we sort of wanted to, rather than replacing it sort of seems safer to sort of start small and make sure it works on Tide and then extend it to the rest of the components, rather than in a single release have the way that we are doing all of our writing for pod utils and whatever, to have everything switch over all at once seemed a little maybe not the best way to roll out this change. But yeah, the intent is to have everything support S3.
Cool. Next PR I wanted to call out was something from Travis Clark. He's added support for GitHub added a few new things to its branch protection API, including the ability to require a linear history, which means no merge commits being pushed to a branch, and a more granular access to how people are allowed to manipulate branches. So that's something that our branch protector Prow component now supports. Something coming in from the folks over at Red Hat. So pod utils, when we think of pod utils, I often think of decoration. Don't know if I'll be able to navigate to it quickly enough. Let's find out. Nope. Let me go back and show you an example of how decoration is used right now. So here, the default decoration config. This is something that Prow uses to decorate jobs. I think it's mostly used by Planck, if I remember correctly. And so this has information like what images are we going to use to implement the pod utils, but also some good defaults that can be overridden on a per job level if we want, like how long is the timeout for the job, what's the grace period before we consider the job unscheduled, if I remember correctly, things of that nature. And so this PR, and you'll notice here, this is all under a star. So this is the default decoration config for all repos, all orgs. We have the ability to specify this on a per org or per repo basis these days. And Red Hat has now added the ability to add default resource requests and limits. So if you want to just say by default, any Prow job that is spawned by Prow, the pod will end up requesting such and such CPU and such memory. That is something that we can support now. And again, because it uses the decoration config format, this could be done on a per repo or per org basis. Final thing I wanted to mention, and maybe Alvaro, you can talk to this a little bit more. I know there's been a bunch of work around improving the general performance and correctness of Boscos. And this seemed like a bit of a milestone to remove a global lock in like reconciling all of Boscos's resources. The reason I feel like this is kind of a big deal because it seems like it really brings down the median response time for some pretty critical Boscos operations.
Yes, so the way Boscos used to work up until this pull request was that it had a global lock that basically was acquired for each and every request ever done to it, which consequently basically means that all requests got serialized, and that in turn meant that the whole thing was pretty slow. And what was done and for which this pull request was the last bit is that I changed Boscos, which is internally based on custom resources that get updated, to internally also use these custom resources, which means that if a resource is changed because, for example, a client tries to acquire it, and another routine changed it in the meantime, so basically after the request came in, but before the handler updated the resource, then the Kubernetes API server will reject the request because it got updated in the meantime. And this allows to basically just remove the locking and rely on the Kubernetes API server rejecting requests for things that got updated in the meantime. And to make sure that client don't see a lot of this, because this basically means that we expect sort of regularly update requests to fail, is this is made possible by just retrying on this specific error. So this all in all required some more refactoring within Boscos, but makes a huge difference for its latency.
Cool, thanks. So that's all I had to talk about in terms of interesting stuff that merged since we last met. If there are no questions, I will hand off to Eric to talk to us about workload identity. Take it away.
Cool. Oh, and one more thing about the Boscos is, I think it's nice that sort of seen, recently more participate. I don't know. It seems like there's been more improvements to Boscos lately, which I think is a nice change. So thanks for doing that. Let's see. So workload identity is, I put some links on, and I guess are you gonna, Aaron? Would you be able to pull up any of those links, or do you want me to do that, or how would you prefer we do this?
I can.
Or do you just want me to talk?
I can pull them up if you want me to be your remote hands. You just tell me when to go where, I guess.
Okay. Yeah. So I don't know. I guess the maybe show the first one, the sort of just general. There's a link on the test info. There's a workload identity. So workload identity is a feature that is part of GKE that allows you to sort of associate a Kubernetes service account with a GCP service account. So historically, the way that we have been identifying, authenticating with GCP is by, you have like a secret JSON file, and then there's some, fancy shenanigans where you pass that secret to Google, and then they give you back a short-lived token, and then you can send that token to various things like cloud storage to authenticate as whatever user you are. And this is a way to sort of make that happen in a different way by sort of saying that like this service account should always authenticate automatically as this GCP service account. And so you can see that there's sort of the documentation on that page that talks about how to declare that, which is, I think, one of the things I'm excited about is that it sort of is declarative, and so it allows more self-servicey stuff to where you can sort of just, rather than like right now, if there's a secret that someone wants to use in one of their jobs, there's not a great self-service way of doing that. They have to like hand the on-call team that secret and hope that we upload it correctly. This is a way where you can just declare in a file with a PR that like, here is the service account I want to use on my pod, and here is the GCP account I want it to authenticate as. Like in the middle of the screen there, you can see that service account name is something. So that's essentially what you do in your pod when you define the spec, is you say, here is the Kubernetes service account I want it to act as. And then when you declare that service account, you say the GCP binding that you want it to have. So those are kind of the two things that you need to do. You need to declare a service account and annotate it with the GCP service account. And there's a command you need to run on gcloud to make sure that the service account is actually authorized to act as that GCP user. And then you need to make sure that the pod is actually using the Kubernetes service account that is able to act as the GCP service account. And so, yeah, the past, few months, I guess since the beginning of this year, maybe a little bit before that, I have been, with varying amounts of success, converting our Proud deployments, our K8s Proud deployments to use Workload Identity. And that is mostly finished. And yeah, so let's see. So, for the most part, it was pretty simple. Most of the Google client libraries know how to work with this already. So it mostly just involved things like that, where we have a bunch of places in our code where we, assumed that you had to have these, you had to have the secret file. And so if that wasn't defined, the script would blow up. And so most of the changes I had to do were sort of removing requirements on this secret file existing. And if that isn't, defined, then Workload Identity, just gcloud or the, storage client libraries work correctly. But we had sort of coded in places where we expect it to work. And so given that, we always use that, I was expecting, it to not have I was expecting it to be similar to changing the GKE version or something and sort of be transparent. We haven't really migrated any of the bulk of jobs, like most of our end-to-end jobs are not using it yet. But by turning on Workload Identity, you wind up using a GKE-based metadata server, and that turns off the GCE metadata server. And sort of an assumption I had is that we weren't using this anywhere. And so that has, proved false in a couple cases. Like this is one example of an outage that's turning on, on the cluster, I turned on a Workload Identity, and that wound up breaking this code path, which I'm not exactly sure what it is. Maybe it was like trying to find, I think it was, I don't know, it was doing something. But it was explicitly talking to the metadata server. And if you do not specify a Kubernetes service account for your job and you turn on Workload Identity, then the metadata server won't give you access tokens anymore. Like before, there are some scenarios where you can wind up sort of acting as the VM instead of the pod. And so that broke. Which was sad and unfortunate. And Ben helpfully, I think with some other people, helped figure out what it was. And then there's this, there's sort of, rather than curling the metadata server, there's a gcloud command to print the access token on those green lines. And that will know whether or not to use the secret file or the metadata server based on what's configured. And so since we are passing the secret file into this job, I was a little bit surprised that we were not using that to get the credentials. And that probably also wound up, it was like authenticating as the wrong person or whatever. So potentially good to discover that, but ideally we would have discovered that ahead of time. Yeah, and yeah, so here's maybe a more complicated change. So inside of Google, we have some private results. And so Spyglass has a way to show, it can show you the logs for private results. And that involves giving you a signed URL where it uses the secret JSON file to sign the URL. And obviously, if you do not have a secret JSON file to sign the URL, right now, there are ways to use the metadata server to sign the URL, but the storage client libraries don't support that yet. And that's actually something where we'd have to, I don't know, essentially that didn't work. So for right now, there are some scenarios where we are still using the secret file. And this was an example of me migrating it to support cloud storage can also authenticate with a cookie. Like if you're logged into Google, it can just use your authentication to download the file. And that's obviously going to work inside of Google since we are all logged into Google, but that may or may not be the best, a great scenario for, for other people. So this is an option that you can now turn on. And then hopefully eventually we will update, the client libraries will get updated so that they can sign the URL without needing the secret file. So, I think the next steps, so one, I think important thing to learn is that, my assumption is that since all our jobs are using the secret file, that this wouldn't cause any outages, and so didn't need a heads up was wrong. And, so maybe we should be a little bit more careful about, those sort of a list of various things that have been happening to make this happen. And yeah, so, I think we need to continue to be careful about, things that we think should not cause outages, obviously can. And then the next step will be to start migrating our jobs. And yeah, so there's a bunch of, there's the README to follow. And then also the, there's a bunch of PRs there of some various other things that have been migrated. So at some point we'll need to, create a campaign to help people convert those over. So that is, sorry, that took a potentially long time. But yeah, that's sort of workload identity.
Cool. I had one question on the jobs front. I'm just trying to find like an example. Are the jobs that use Bootstrap able to use workload identity?
Yes. I mean, I mean, yeah. I don't know. I mean, if you, yes, like it should. There shouldn't be any. I mean, anything that's going to interact with Google will know how to work with the metadata server, which is what workload identity. Workload identity is essentially a GKE implementation of the metadata server that is normally on your VM. And so yes, essentially if you just remove authentication, if you remove like explicit file-based authentication and add a service account, it should use that to authenticate. I wouldn't be surprised if there are similar things where like we, so like if you see on line 29, that preset service account, that is going to be injecting a environment variable as well as some volume mounts that have the secret. And so since theoretically, if you remove that, it may or may not work. We haven't done any of that on any of the jobs. So I wouldn't be surprised if there's something somewhere that, that requires that file to exist. And so we need to fix that. But otherwise, I wouldn't expect to see, otherwise it should more or less just work.
Okay. Any other questions for Eric? I guess my other question is, this seems like it's going to be a great way to deal with secrets for things that need to talk to Google. But for things that need to talk to other clouds, I'm assuming we're still just going to be passing secrets around and stuff like we have been. Is that correct?
Yeah, I mean, I think we can solve that, but it wouldn't, I don't think necessarily workload. Yeah, I mean, we'll need another solution. With the idea for, I think the main benefit with workload identity is that since there isn't a secret file that you're injecting into the container, it is impossible for, a rogue job to steal that secret and then go move it into, its botnet or whatever and start authenticating to somebody. So the nice thing about that is there's nothing to steal. But yeah, for other systems that, we'll obviously need to continue using secrets. And I have some ideas for how we could make that self-service, and we should, but it'll require a different solution. Workload identity may potentially help there, but it is not, yeah, making that self-service is another project.
Okay. I think there are some folks in the K-Infra working group who are toying around with the idea of, I'll stop sharing, with the idea of using the KMS and seeing if that's something that could be used by Google Cloud Builder to avoid having to pass secrets around.
Yeah.
Any other questions? Okay. Next up, Catherine, can you walk us through this proof of concept you did to run make tests on Kubernetes?
Sure. I don't have anything prepared, but I will wing it. And I opened some browser tabs, so I will share them. Share. Cool. Okay, so basically, there is a substantial amount of interest in the community in removing Bazel from Kubernetes only, not test infra, but Kubernetes, as it causes a whole bunch of friction, which is not necessarily required when updating things, and also when people are just going about their days and suddenly, thanks, GitHub, was not even touching my computer. I don't know what I was saying. Anyway, people want to get rid of rid of Bazel in Kubernetes, which sounds nice potentially, but there are a whole bunch of reasons Bazel is useful to us, and we would have to deal with some of those. One of the ones that I am more familiar with is the fact that we use it extensively in our CI infrastructure in order to speed things up, and it is really quite fast. If we look here, this is our pull Kubernetes Bazel test job. It runs on every Kubernetes PR. It takes 10 to 20 minutes most of the time, which is a reasonable amount of time, and compared to some of our other CI jobs, it's much faster. But if you run make test on its own, then you lose a bunch of the fun caching that we get out of Bazel when combined with either Greenhouse or RBE, remote Bazel execution. And then you end up with really slow test times, which can be north of an hour, depending on the node that you get jump turn on the build cluster. So we can, since we started off on all this Bazel adventures some years ago, Go has grown its own caching mechanisms, which we can use in place of that, if we can persist them between CI jobs. So I basically built a very simple thing that will, as a proof of concept, it will generate basically a make test cache taking the full time it takes to build tests. So here it's taking 30 minutes to an hour, sometimes it's slower, an hour and 17 minutes there. It's also always failing, but that's just because there happens to be a bad unit test in KK that always fails, and not because these jobs are bad. I have a PR out to fix that. So this is just generating the test cache, and then later, if the Zoom UI stops being the way of my tabs, how do I make that go away? There we go. Oh, crying out loud. So then we can have jobs that use these pre-generated build caches, and they run much faster. They are comparable with, or even faster than, the Bazel tests, often running in less than 10 minutes. If there is a substantial delta where a bunch of tests have been invalidated since the cache was made, they will be slower. I don't see any reason. Oh, here's one. This one took 26 minutes. But in the general case, for most PRs, it will be at least as fast as it was before, which is really the important part. And you can see it's actually, with the exception of this one bad test, fairly stable. We have one flake here, but other than that, we're pretty good. And we're going to move or remove this bad test, which assumes it's in a privileged container. What was this next one? So yeah, I don't know why I had this tab. You can see that it worked. The actual implementation here is super trivial. Basically, we have this job that generates the cache. So it literally just runs make test and then zips up the cache and sends it off to GCS in some predetermined location. And then when we want to run the job, we pull the cache back out of GCS, unzip it in the right place, and run make test. And it's much faster now because we already have the cache. So this is built and will be relatively easy to apply to our actual PRs. The other thing that we actually care a lot about is the time it takes to build Kubernetes images, and that is harder to speed up. So that is basically the equivalent of make quick release and is used in PRs both for our end-to-end testing, assuming we keep doing that, and also for an equivalent to the pull Kubernetes Bazel build job we have, which makes sure everything actually builds. Speeding that up is more work. It's very slow, even on local machines, which would be frustrating to the few people who actually use Bazel. So there is work needed to speed that up more generally, perhaps. And caching it is somewhat trickier as well, especially since it spends a whole bunch of its time just tarring images. And the Bazel version of that is really fast. Well, really fast, relatively fast. And the make test version can take like half an hour, which is not so good. In particular, when we use the cache in the GCE tests, it gets through the stage in about 5 minutes, which is much faster than the 30 or so minutes it takes to build K8s in CI. So there is work to be done there that is not yet solved, but is probably solvable. That is what I had to say. So I'll stop sharing now.
I just want to also mention that the Bazel-build job also includes a lot of things that are being built that are kind of unclear that they should continue to be, a few of which are probably slated for removal from the repo even. So at least some of that problem will just sort of solve itself.
So this is maybe a question on just how the Go test cache works. Does the test cache prevent us from rerunning unit tests that like already passed when you made the cache?
It does, and indeed so does the Bazel cache, which is why we currently have a bunch of flaky tests we don't know are flaky because we cached them passing once and never ran them again. I don't think that we want to get rid of this behavior in PRs, which would just be deeply aggravating. I think there is value in having a CI job that just runs for tests with no cache regularly, and indeed runs from a bunch so we can see which ones are flaky and send angry emails to people or something.
Okay, that makes sense. My other question is, I guess you make it sound like the bulk of the time in building Kubernetes is spent tarring things up and building images. What about just building the
so
code?
So the build process that builds images is wildly slower than the one that doesn't build images. The fact that it's building images is not intrinsically a major part of that. That's only actually a couple of minutes spent. So work is needed on the build scripts to improve that behavior, I think. Which would benefit everyone in many places.
Okay. What do you see as next steps for rolling out these cached unit tests that don't use Bazel? Should we push the release team to start relying on these instead of the Bazel-driven tests?
So I think to start with, I would start by having them be non-reporting pre-submits and have more and make the cache generation happen more frequently and rely on the previous cache generation. I'm not sure that I necessarily want to say these are the primary unit tests unless we actually agree that we want to remove Bazel, which has not been finalized. And a substantial part of the reason I'm doing this work is to determine whether removing Bazel is feasible at all.
Yeah, no, I completely understand there. I feel like, yeah, we as a community need to actually understand the work involved in removing Bazel from our system, because I don't believe it's just as simple as deleting all of the build and workspace files and getting on with our lives.
No.
You've pointed out a fair amount of functionality that people who open pull requests to Kubernetes rely on. and I guess pointed out a little bit about the local development experience, though it's unclear to me how many people use Bazel locally.
I think very few, but for people who use it, will be really sad if we don't make sure their builds are still relatively fast.
So I know a number of people actually don't use either of the builds when they're doing local iteration. You can just like go build most of the binaries, and that's quite fast. It's actually much faster.
It is, and caches. It's just building the images, which is super slow.
Yeah, and I think that there's some very low-hanging fruit on the image builds. They date from a time before Docker even had build arguments. They're incredibly archaic and involve exciting things like writing out a build like a Docker file just in time and then building it.
Hey Google, turn the lights on.
I don't think they're anywhere near close to efficient, and I don't think it'll be too much work to do that. The thing that's probably the most slow is the fact that we also do the Dockerized build for the binaries we stick in those images.
Yep.
It's also unclear why we still do that. Going to need to do some archaeology there.
I would imagine maybe part of it is for those of us who develop on a MacBook, we still need the ability to build the Linux binaries for deployment and such.
Yeah, but that's not relevant for anything that goes into an image. It's only relevant for kubelet, which needs SIGO. For all the rest, we already compiled them with like SIGO off and cross-compiled. So like that would work fine. And kubelet doesn't go into an image.
I remember that for a while, part of the reason why we built things in a container is because it was annoying dealing with everybody's, like we initially tried to support Mac natively, and they have super old versions of like things like Bash. But I think these days we just require people to install more updated versions of those utilities. So I don't know, maybe they're similar. I feel like there's probably a lot of modernization things. You know, in my ideal world, I don't know that I've had much success in trying to drum up this interest, but you know, if Bazel fans are so excited about Bazel, I think it would be interesting to see whether there is, you know, any ability to make the annoying parts of Bazel less annoying, which would potentially, you know, also address certain things. Like, I think that, you know, like, for example, a big part of I feel like the primary motivating factor of irritation is like the build files, which are in every directory, which really don't need to exist because they're literally, the way we create them is with Gazelle, and that just calls out to go to get the list of like what imports what, and then converts that into a build file. So
there is some amount of manual things in there to work around things that rules code doesn't quite support, mostly again around like SIGO.
Right. Yeah. I mean, yeah, you know, but I think in an ideal, you know, world, if Bazel prioritized these types of scenarios, like theoretically, it could, you know, be better and not so obnoxious. I think the nice thing about test infra is that you know, it allows building different languages. So yeah, but yeah, for, you know, given that Kubernetes is just Go, it has substantially less marginal value there.
Yeah, and as these tests show, Go's caching system is actually kind of Bazel inspired, but it's quite good. It's pretty optimal.
Right.
What I think one thing that didn't get brought up is the size is quite good this way. It's more space efficient, which is helpful because we have to download it.
Yeah, actually, the size of so for make test, the size of the cache is 2.3 gigs, I think, off the top of my head. For building everything, it's about 3 gigs. A Bazel cache for the same thing gets to north of 40. Somehow.
What do you mean by Bazel cache?
So while we don't care, because this isn't how Bazel caching is actually works or used, but if you generate a Bazel cache, if you do the same thing and just like grab the Bazel cache after a build, it is huge.
Yeah, I think I might be, maybe this is saying that wouldn't work, but like we also have slowness. We spend a lot of time with every job downloading the Bazel rules. Be interested to see if we could speed that up for like some of our jobs that do use Bazel. It'd be nice if they could just start it being ready to run and not have to start downloading the proto rules and the Go rules, etc.
Yeah, I think there's room to improve that. I think it's probably harder because of this combination of size and Bazel behavior, but I have not investigated in depth.
Cool. Yeah, that's a neat proof of concept. And yeah.
Yeah, I agree. That is a very neat proof of concept. I guess my other random question is, Kubernetes isn't the only repo that runs Go test. I'm sure we have a number of other jobs that could benefit from this pattern. I'm wondering if there would be sort of a more, I hate this phrase, proud native way of doing it, such that people didn't have to kind of create these boilerplate jobs and such to accomplish it. Because my understanding is you sort of have to have a cache creation job for any equivalent job that you would want to be cached.
You could skip the cache creation job if you just had every job update the cache after it finished. You have, I think there's more room for interesting races there, but it would more or less work, and it is how like Travis and the like handle their caching. They also just take the cache directory, zip it up to S3, pull it back, and reuse it in the next job.
They just upload the cache of any job and then use it for the next, or of any one, and then use it for the next one, and they don't do anything like only upload on base branches or something?
I think so, yeah.
Oh, okay, interesting.
I would worry about the security behavior of that if we're using it. I would not want to use that for pull requests.
Yeah, I didn't go for that approach because I think there are a number of potential issues that we haven't thought through, and possibly they either have thought through or didn't and don't care. But I think there are probably ways to make recipes for this, but I'm not sure where.
Yeah, I prototyped something like this in kind and tried to make it kind of generic. I think the main thing is it just depends on exactly how the rest of your job's going, because you need to hook kind of before or after doing something, and like maybe someday with Tecton or something we'll have a way to do that, but right now there's not a really like proud native way of doing that sort of thing.
Pod Utils could do it.
That's the direction.
Not sure if pod utils, but we could like have a post-stop hook that just uploads the cache.
Yeah, like I could maybe imagine pod util. Well, I don't know.
It will get a little bit awkward because for it to be it will need, like, you'll need to have arranged for that to also be a volume and for things to have written to that specific place.
Mm-hmm.
I think you can just force that by setting the go cache env, and this way you both force that it gets written to this location, and like you can put it into that location. So that could be one idea. But yeah, it needs a bit more thinking.
You end up with fun things like Kubernetes actually overrides your Go cache environment variable because it's Kubernetes and will never do what you think it should do. But yeah, there are things you can do like that, but would work in most cases.
By the way, Stefan is now on the meeting, and I don't think he was initially, but we were talking about your PR to add S3 support earlier. So thanks for that. It's pretty cool. And thanks also for working through lots of different, rounds of reviews. So that is cool.
Yeah, no problem. Yeah, just joined now because I just recognized that the meeting is already going on. Yeah. Yeah, so I will have some follow-up pull requests. I didn't really have it prepared for now, so I'm not sure if we can discuss some of it, or maybe I just put some discussion points on next pull request and discuss it there. Probably better prepared this way.
Yeah.
But I think so. The general idea would be in my mind right now. So the next pull request would take a look at a GCS upload package and sidecar and init upload, how to refactor this part, and pull requests after that interaction of DEC and Spyglass and yeah, all that complicated stuff with paths and yeah, mapping from DEC URLs to storage paths and back and forth. Yeah, something like this.
And so do you have a version of Crow that you are using that has all of this mostly working?
Yes. So we're using S3 tied init upload status reconciler, DEC, Spyglass, not Crier and not Garrett. But yeah, we're running it since, I don't know, 6 months or so. And it works pretty good without any major bugs or something.
Nice.
So I have a target I have to work towards too.
Yeah.
Yeah, that's really cool. Thank you for working to get support for this upstream. We really appreciate it.
Yeah, thank
you. Well, I think we've hit the end of our agenda. And I'm happy to give everybody about 10 minutes back, unless there's anything pressing we'd like to discuss for the remainder of our time here. Okay. Thank you all so much for your time. See you again in 2 weeks. Happy Tuesday.
Bye.
Bye.
Bye.